Hi everyone, and well done for finding your homework video. It's the first of two videos about fractions, and it's the Getting Secure version. Fractions is a big and quite a complicated topic, so we're going to break it down into two videos, and today we're going to have a look at three of the areas. We're going to have a look at finding equivalent fractions, we're going to look at finding fractions of amounts, and we'll look at ordering fractions. And then next week we'll have a look at adding and subtracting fractions, turning fractions into decimals, and also looking at mixed number fractions. To understand equivalent fractions, we need to get the idea that fractions can be the same, but they can look a little bit different. Take 2/3 and 4/6, for example. We often talk about the part and the whole, that 2 parts of 3 is 2/3, with 3 being the whole. If I have a look at the circle here, there are 3 parts, the bottom bit of the fraction, and we have 2 of them shaded, so it's 2/3. Now, the thing that you need to understand is that that's actually the same as 4/6. If we have a look at this one, the part is 4, there are 4 parts, the whole is 6. Now that's the same amount of space as 2/3. Now obviously it looks different, it's 4 out of 6, so in that way it's different. But it's also the same in that it's the same space. Have a look at the bottom example. Here, for every 2 that are shaded out of 3, that's the same as shading 4 out of 6, because again here, for every 3, 2 are shaded. It's just we've got twice the number, but the fraction remains the same. Here's a real world example. So this is a real article, and it tells about how English is a language that 2/3 of Europeans can speak. Now, the part and whole fraction there is 2 out of 3. Now obviously there aren't only 3 Europeans. In fact, there's more like 300 million, and 200 million will be able to speak English. But the relationship stays the same. For every 3 people, 2 can speak English, and that's the same as a fraction as 200 million to 300 million. Now, I want to see if you can use your understanding of equivalent fractions to work out 2 different fractions that are equivalent, the same as 3/5, using the number 15. You need to work out what the numerator for this fraction must be and what the denominator for this fraction must be, so that both are equivalent to 3/5. Pause the video and have a go. So for the first one, I know that I need 3 lots of fifths to make it out of 15, so that means I need to multiply the top of the fraction by 3 as well, so that means that 9/15 is the same as 3/5. For the second example, how many 5s to make it out of 25? Well, that'll be 5, and I'll have to multiply the top by the same, by 5 as well. 3 5s are 15, so 15/25 are the same as 3/5. Of course, it looks different, but it's the same. Now, in the same way that we can multiply fractions to make them bigger, we can also divide the top and the bottom by the same number to cancel them down, to make them smaller, to give them in their simplest form. I want to see if you can change these 2 fractions to make the numerator and the denominator smaller, but keep the fraction equivalent. Have a think about the number that the top and the bottom both divide into. For the first example, 60 out of 100, well, if I divide the top and the bottom by 10, that will make 6 out of 10. And 6 out of 10 I can cancel down further, just by halving it, to make it the same as 3/5. In the second example, 9 and 12 both go into 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So 3 out of 4 is the same as 9 out of 12. I need to use a linked understanding of fractions when I'm working out fractions of amounts. Here, if I'm working out 4/5 of 30, I need to split the 30 into 5 pieces, the whole. 30 into 5 is a 6, a 6, a 6, a 6, and a 6. That's 30 in 5 pieces. Now, if I'm after 4/5, I'm going to need 4 of those 6's, which of course would be 24. Now, you might notice here that 4/5 equals 24 out of 30. An equivalent fraction. Multiply the 5 by 6 to get 30. Multiply the 4 by 6 to get 24. Have a go at these two questions here and see if you can work out the fraction of each amount. Pause the video. For the first question, we need to split 800 into 4 pieces. Each piece then would be 200. 200, 400, 600, 800. And I've got 3 of those quarters, so I must have 600. Similarly, if I split 40 into 5 pieces, each piece is 8, and I'll need 2 of those pieces for 2/5, and that would be 16. Now, when we're ordering fractions, we often use a fraction wall to help us to visualise what the fractions look like. What I want you to do is pause the video and see if you can work out of each pair of fractions which one's the biggest and how you know. Finally, have a go at ordering these fractions. My suggestion is work out which ones are more than half, and then see if you can convert the fractions so they're out of the same denominator, so the bottom of the fraction is the same. Pause the video and have a go. This is your final question. Now, my first tip was to work out which fractions are more than half. Well, I actually know that my smallest one is a half, because half of 4 is 2, so that one must be more than half. Half of 16 is 8, that's more than half. And half of 8 is 4, and 5 of course is more than half. So half must be the smallest one. Then I'm going to convert my fractions so they're all out of 16 of the other ones. 9 out of 16 is already out of 16. 5 out of 8, I would need to double the top and the bottom to make it 10 out of 16. And 3/4, well, I would need to times that by 4 to make it out of 16. 4 4s are 16 for the bottom of the fraction, so I'd have to times the top by 4 to get 12. And then I can compare my fractions. I can see that the next smallest one is 9/16, and then it must be 5/8, because that's the same as 10/16, and then the largest one must be 3/4, because that's the same as 12/16. Well done. We'll see you back in class, and look out for the next homework video which explains fractions even further.